In this video, I'll demonstrate how to use the different fit methods in MyAssays desktop. MyAssays offers many different curve fits, weighting models, and goodness measures. These can be accessed and added using the Properties tab in your protocol and selecting a transform which performs curve fitting. The first curve fitting transform listed is the dose-response curves transform. This transform can fit multiple curves to samples, compute values such as EC or IC50, with the results being overlaid on a single chart. The second transform we could use is the general curve fit transform. This transform is useful for fitting a curve to any type of data. It will plot the specified calibration data and use the curve to predict either X or Y values for selected sample types. This transform will offer you the most flexibility to create curves from any sample type. For this demonstration, I'll use the third option, the standard curve fit transform. And in this transform, the software fits the curve to specified standards and computes the concentration of unknown samples using that curve fit. Once we've selected and added the standard curve fit transform, we can see the options available. The first fit we'll discuss is the linear regression analysis. This is a basic fit method that sets the linear relationship between the dependent variable y and the independent variable x. The equation is y equals mx plus c, with the dependent variable or signal being y, and the independent variable or concentration being x. M is equal to the slope, and c is the intercept of the y-axis. Another more common fit is the four-parameter logistic fit, or 4PL. This is a nonlinear sigmoidal model that assumes symmetry around the inflection point. This curve is very useful for dose-response assays and receptor-ligand binding assays. This is the equation here, and you'll remember our dependent and independent variables from the linear regression analysis, although here you'll see we have the addition of four more parameters, hence 4PL. A represents the value at a minimum or zero dose, D represents the value at a maximum or infinite dose, C is representative of the point of inflection. This is the point around which this curve method assumes its symmetry, and B is Hill's slope of the curve, which is related to the steepness of the curve at the inflection point. Another nonlinear fit is the 5-parameter logistic fit, or 5PL. This is again a sigmoidal model that is useful in many of the same biological assays as the 4PL. The biggest difference here between the 4PL and 5PL curve is that the 5PL curve does not assume symmetry around the inflection point. You can see the equation here is almost identical to the 4PL equation, but with the addition of a fifth parameter m, which is the asymmetry factor. When m equals 1, the curve is symmetrical, and you'll see when this is the case, the equation will be the same as the 4PL curve. But just because the 5PL curve fit method accounts for asymmetry doesn't necessarily mean it's automatically a better fit than the 4PL. One of the advantages of the 4PL curve is that in general it requires less standards than 5PL to obtain a meaningful curve fit. MyAssays also includes multiple legacy fit methods like cubic spline, smoothed spline, cubic regression, and point-to-point, just to name a few. These methods were popular when computers were first being used to compute immunoassay results, as these tended to be computationally simpler. Kit manufacturers may still recommend the use of these curve fit methods, however, you may find that a 4PL or 5PL fit gives better results. In addition to these multiple curve fit options already available in MyAssays, you also have the option to define your own fit expression. This can be achieved by clicking Custom under the fit method and defining your fit equation. This function is covered in more detail in a subsequent video. Below the fit method options, you'll find options for weight methods. Weight methods can be used to improve curve fits when the measurement errors do not all have the same variance. The weight methods included are 1 over x, 1 over y, 1 over x squared, 1 over y squared, x squared, and y squared. With all of these options, it could seem a little bit overwhelming to choose the correct fit, but don't worry, we've included a tool to help you choose the most appropriate curve for every dataset. It's called Best Fit. This feature can save you time by automatically determining and applying the best curve fitting method for each run of your assay. And if you're working with multiplex assays, the Best Fit method will pick the best method for each analyte, possibly applying a different fit to each analyte. So to use this tool, from the Fit Method drop-down box, we'll select Best Fit. The Best Fit feature works by evaluating and ranking various fit methods. The first step is to select which fit methods and any weight models you'd like to compare. The default configuration will compare the commonly used 4PL and 5PL fit methods with unweighted and various weighting models. You can select which fit methods and weighting models to compare, but I'll just use these default options. After selecting which methods to compare, the next step is to define what is considered to be the best fit. This is achieved by selecting the fit score method. Each of the fit methods we selected are scored using this scoring method. The method with the highest score is considered to be the best fit. For example, with the R-squared fit score method, the curve with the highest R-squared will be used. We can apply these settings now by pressing Calculate. When the calculations are completed, we can see that the determined best fit has been applied to this analysis. In this case, we can see that the 5PL fit with 1/x² weighting has been determined to be the best fit. On the Fit Details tab, we can see this final table shows the various fit methods that were performed and scored, here ranked in order. You can see how each method compared. The method with the highest score is considered to be the best fit and is used to compute the results. Here we can see the 5PL fit with 1/x² weighting has the highest R-squared. R-squared is a commonly used method to evaluate a fit. With this measure, values closest to 1 indicate a better fit. Taking a look at our calibrators table, we can see that the accuracy of the highest standards, Standards 1 and Standard 2, are above the plus or minus 20% threshold we've set for this assay, and that's why these rows appear in light red. Remember that percent accuracy refers to how close the obtained concentration is to the defined concentration, and percent CV is our measure of precision, or how different the two replicates are from each other. Also, in the Standard Curve Fit tab, we can see here the fit line is further from the standards. Using R-squared as a scoring method can give good results. However, its general nature means there could be a compromise in accuracy at the ends of this curve. For this reason, the software also provides further scoring methods to take into account both R-squared and accuracy at the ends of the curve. To improve the accuracy at the high end, let's use the R-squared with high-end accuracy scoring method and recalculate our results. Using this scoring method, the best fit has now been determined to be 5PL with x² weighting. And scrolling down, our calibrators table now displays all standards within the accuracy threshold of plus or minus 20%. Further scoring methods are available, including 1/standard error, which will pick the fit with the lowest standard error. This is another good choice, especially when comparing different fit methods. Similarly, 1/p-value will pick the fit with the lowest p-value. Also, the various AIC and BIC scoring methods apply further, more sophisticated analyses taking into account the complexity of the fit, with fit methods that are simpler scoring higher. More information about exactly how each scoring method works can be found in Help. Help can be accessed by clicking this blue question mark anywhere within the software. You'll also find more information about further advanced options, including how to define both your own fit methods and your own scoring methods, enabling you to further customize the best fit feature. If you have any questions, please email us at support@myassays.com.